Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, you've got everything you need to run a fast, reliable, and bulletproof data platform. And for your machine learning workloads, they've got dedicated CPU and GPU instances. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. Your host is Tobias Macy, and today I'm interviewing Kenny Gorman about the Eventador streaming SQL platform. So, Kenny, can you start by introducing yourself?
Hi, my name is Kenny Gorman. I'm co-founder and CEO at Eventador.
And do you remember how you first got involved in the area of data management?
Sure. So my background's actually as a Oracle DBA way back when. I worked with my co-founder many years ago now at PayPal and eBay, and that's actually how we met. He was at eBay, and I was at PayPal, and we had some significant database problems back then, scaling those stacks. We were both relatively early on, and we had problems in the Oracle database realm that others hadn't seen before. And we worked on some of those hard problems around storage and Veritas and Oracle and Sun systems, and both started working together and really enjoyed each other's company and fixing hard problems. And yeah, that's really kind of where my love with data systems and databases and streaming systems really kind of started.
Yeah, the early days of the web were definitely an interesting time for actually finding out what the limitations are of the systems that were available at the time.
Yeah, we had this one thing. It's just kind of anecdotal, but it's kind of funny. We, you're supposed to be able to add a column to a table in a relational database just in real time. Like there's no, locking behavior really to that. You're not like locking up a table or causing some sort of semaphore. But ultimately, under the covers, you are. And our database was so busy that we couldn't even do these things in real time on production systems because of there was no time to get latches in the system. And I remember looking at the Oracle guy next to us who actually worked for Oracle, and he's like, "Yeah, we haven't seen that before." I said, "Okay, well that's great. We're in uncharted territory here." Good times.
Yeah, that's definitely great when the people who build the system say, "I have no idea."
Right.
And so starting there, I can see how the interest in data has continued, and I know that you've also been involved in the Object Rocket platform and most recently with Eventador. So I'm wondering if you can just start by describing a bit about what the Eventador platform is and some of the story behind it and how you came about founding it.
Sure. Yeah, I'll just kind of tell you what Eventador is real quick, and we can kind of, go back and talk about how we got here. But essentially, Eventador is a platform that allows you to build applications on streams of data. The design was that we wanted to allow developers and data scientists and backend engineers and folks to be able to just query streams of data, just like it was a database. And, Kafka and streaming technologies and the distributed log have kind of taken off in the last few years. But ultimately, it's very hard to kind of make sense of that data, kind of wrap your head around the new paradigm of streaming data, and then, ultimately like building applications that are really cool on top of those data streams. And that's really what the Eventador platform is designed to solve all in one. And the idea kind of came about. So just to kind of a little bit of history, my background, again, my co-founder, myself, Eric, were working on MongoDB problems actually around 2010. And we started to figure out that MongoDB, back then it was very early. I think I was one of the first few customers who really used it in production and fell in love with it. It was awesome. But it had some quirky corner cases where it just didn't work very fast. It had a heavy-duty locking kind of design for the database engine, and it made it slow under certain circumstances. And so we kind of figured out that like a lot of that had to do with I/O and started building around SSDs. Sure enough, it's kind of a brute force, mechanism, but SSDs made Mongo very fast. And so using some of the projects that came out of Facebook where we could do hybrid SSD and file system layers, and then ultimately just pure SSD, we figured out that Mongo could just be really, really fast. And we started to kind of build a product around making MongoDB enterprise grade is kind of what we called it. And that's when we founded Object Rocket and ultimately sold that to Rackspace and grew that business to be a relatively big business. But along the way, we started to have a lot of our customers. And at this time, we had billions and billions of documents under management. It was just, in Mongo, it's a document, not a row. But ultimately, billions and billions of rows under management. And customers were asking us these questions like, hey, how do I, get a millisecond response time on this 2 billion document collection? And the answer was like, you're never going to get that. Theoretically, disks have to move to make this happen, or, buffers have to be retrieved. There's so much, index retrieval plans have to be followed. There's just a ton of work under the covers for a database engine to return the data in that kind of a mechanism, and it just wasn't really feasible. And so we started to ask, like, well, what are you doing? Why do you need to have this type of performance from your Mongo cluster? What's the thing that's driving this? And it was these really kind of new school use cases where, for instance, and I won't mention the customer, but it was like, imagine if you wanted to look around a room and find a date, and you wanted it to be very centric to the people that are in that room at that time. Maybe you're at a place having dinner, or you're at a bar or something, and you wanted to get a sense of the customers that could be available for dating in the room. And we thought, well, okay, that's going to very, very real time kind of a situation. People are coming and going. How are they tracking this data? And more customers started to kind of have these use cases in similar ways. And we thought, okay, there's a pattern here. And this is super interesting in terms of database engineering. How is the world going to handle these kinds of requests and use cases? And if applications are really being designed with this kind of sensitivity towards performance and real time, then there's got to be data systems behind them. There's got to be a backbone to make this work. And that's kind of when we fell in love with Kafka.
And I know that there was also the heyday of RethinkDB that was trying to promise some of that same capability of push-based data delivery, where as soon as a record was entered into the database, you could subscribe to that and then get a push notification based on that. And I'm wondering what the differences are in terms of the capabilities of how RethinkDB was approaching things versus what you're able to build out with something based on Kafka and some of these stream native data platforms.
Right. No, that's a very good question. I think ultimately we can say at this point, like there's different technology stacks that we've employed for various uses over the years, right? And in my mind, and I think it's a relatively popular opinion, is that the data sphere is not shrinking, or it's not one technology or another technology. It's really that as a data engineering professional, we have more choices going forward. And now it's up to us to pick the right platform or choice for the particular use case. And I think, in terms of real-time things, distributed log architectures, whether it's, Kafka or Pulsar or something else, are fantastically cool and fantastically high performance because it's an append-only structure. I mean, we did this in databases way back when we had to make the database super fast and had to handle a lot of inserts. We would just, we wouldn't do any updates. We just have to, make it an insert-only table. And that's a very kind of old school and crufty way of doing a similar kind of thing. In fact, and it should be obvious that all the databases, most popular databases, have a distributed log built into them. It's for their recovery structures. So Oracle has a redo log, Postgres has wall logs. Ultimately, these are append-only designs, and they're that way for a reason. They have to be high performance, and then, they're typically designed to replay a stream of events. If you just pop that out of the database, so to speak, and create a new infrastructure piece based on just that, you kind of end up with something like Kafka. And at least that's how I think about it. And so that's really the right architecture. It's not really a database, but it kind of is. And I think that the hybrid of this pub/sub style of interface with a durable and distributed backend is really the sweet spot for a lot of these architectures.
And as you mentioned, there are a few different approaches to this streaming and event-driven capabilities. And in recent months, there have been a lot more projects coming out to focus on being able to provide SQL interfaces on these streams, particularly in things like Kafka or Pulsar. And I'm wondering how the capabilities of what you've built into Eventador and the overall developer experience compares to some of those other systems, such as KSQLDB or the SQL layer built into Pulsar, or recently the Materialize project.
Right. So first of all, it's super exciting that we've seen so much energy in this space. When we first started Eventador, our initial prototype involved SQL. In fact, it involves Pipeline DB. We actually used, and now that's part of Confluent. And those guys are super smart. Pipeline DB was super cool. It was built on Postgres, but it really, we used it because it made it obvious that we needed a SQL layer, and it made it obvious that you needed to be able to materialize results. The only problem was it just didn't scale like something like Flink. So, we set off building our service kind of without that and built it from the ground up to what we have today. If you're looking at, kind of KSQLDB and where that's at, it's obviously very Kafka centric. It's built into Kafka. It uses Kafka for scalability and command and control and coordination. And that's fine. That's great. That's a great tool. I think what we view ourselves as is more of a platform, soup to nuts, start to finish, top to bottom, ingest to application kind of capabilities for the enterprise. And I think that's kind of where our heads are at is, hey, look, you're going to need to have schema detection tools. You're going to need to have a procedural logic and on-the-fly creation of user-defined functions and things like this. Enterprise features that when someone's really serious about SQL and productionalizing jobs based on SQL, that's where we fit in real nicely. The materialized guys, the super smart guys, great product. Obviously, it's built with different languages and such, and on the Timely Data Flow platform, very cool. And it's been great to see kind of where the energy is going. A lot of cool innovation happening in our space. A lot of really smart people are working on it. I think we're humbled and excited to be part of it. So yeah, just kind of excited to see how things go from here.
And in terms of the main use cases that you're seeing people using for these streaming SQL applications, you mentioned at the outset the sort of location-based and very real-time nature of the application that one of your first customers was looking to build. I'm wondering, what are some of the other ways that you've been seeing the platform used and how it fits into the overall application architecture and how people are reconsidering the ways that they build and deploy the types of applications they're building on these event streams?
Yeah, that's a good question. So, the major industries or verticals or whatever you want to kind of say that are sort of early adopters in this whole realm. We've seen fintech be a big part of that. Obviously, processing financial transactions real time is important. Doing things like fraud detection, like anomaly detection is a big part of this for fraud pipelines and other patterns. We've seen it everything from kind of cryptocurrency to traditional banking and all over the place, including things like, micro loans on checkout and all those kinds of different, subsets of the fintech space. So that's really exciting. And I think there's a ton of area to innovate there for cool products and services from various vendors. I mean, you see kind of Capital One leading the charge there. It's just, customers are growing to expect more real-time applications, and they want to be delighted when they use their iOS app or log on a web page or something, and that data is refreshed and interacted with in real time. And I think that's really where streaming data, comes in is fintech and banking has been so batch for so long that, any kind of real-time product that kind of comes in can be such a game changer and a competitive advantage for a company. So that's one big one. We see NetSec a lot, network security in terms of things like, obviously, finding anomalies in attack vectors for intrusion detection. Obviously just the raw data of packets, flying over networks is an interesting streaming data problem in and of itself. So we see some traction there. IoT is obviously that's a very broad, bucket of use cases, but everything from the mobility space to automotive and to aerospace are kind of the three big ones there where folks are trying to make sense of streaming data. In general, this IoT is interesting because data is being generated at a massive rate, sometimes, more than once a second, an event is being produced. And then aggregating those events, like in some sort of real-time ETL pipeline, is very interesting and required in many cases. And then in a lot of cases, how they materialize that data out to apps is a problem space. So it's very common today to take your data and put it into Kafka because that's easy. It's easy to just publish some data to Kafka. Cool, no problem. But it's also very common to then pull it out of Kafka and stick it into a database. And that's so that you can materialize it and read it with apps. And, what's interesting today is that kind of ruins the whole point of a streaming architecture. It is kind of going backwards to some degree. And the reason that's very common is because again, like I said, it's hard to materialize those results. So one of the things that we've built into our platform is materialized views. And that just allows customers to skip that entire database layer and read right from the streams. And that's important in IoT, especially because there's just so much data. The aggregation and storage of it is a big problem space. And then I think lastly, real-time manufacturing. That is one that I'm personally excited about, and I think is gonna grow over time. Building better products and understanding yields and how your supply chain and supply lines are working is a real-time problem because there's a dollar value assigned to not doing it in real time. So it's costly to perform poorly in that area. It's also opportunity costs that you could be leaving on the table in terms of being more competitive in your market space and things like that. So I think, that is a super interesting area, and I think it's going to continue to grow. There's, the industry giants out there are leading the charge there and doing very interesting things. And I think, kind of the rest of the world has to catch up, and I'm excited to see that happen.
One of the interesting things about running these aggregates on the event data as it's being transmitted into things like Kafka or whatever your streaming engine of choice happens to be is that in a lot of ways it makes it easier to actually build meaningful analyses on top of it because you already have the context co-located with the data as it's streaming in and the timeliness of it. Whereas if, as you said, you're then replicating it back out into a database, fully normalizing it, it can become much more challenging to be able to run those same types of analyses because of the complicated logic that you have to incorporate into trying to recapture some of that context and time sensitivity to it. And I'm wondering what your thoughts are on the value of actually storing the raw events after it has propagated through the system, and whether you would recommend that it's more useful to store the actually aggregated data into a more long-term storage because the raw events at that point are less valuable in isolation.
Actually, that's a really good question. I think we see it kind of both ways, frankly. Companies are starting to kind of double down on streaming architectures, right? It's starting to become normal to take every click that's ever happened on your shopping site or whatever and jam that into Kafka. That's just kind of normal operating business now. And the question is, like, what do I do with that data and how do I make value out of it? And it's not a one size fits all kind of thing in these architectures. For instance, hey, maybe I want to have a stream processor running on that. Maybe I'm going to run that in SQL. And I'm looking for certain events that are happening. And then I'm going to send an alarm. Like maybe I'm going to send an email out to a marketing team or another area is real-time experiments, right? So I'm running an experiment on my website and, it's not performing. Oh, it's really performing really bad. I want to know that right now because I got to make the change. So I'll run an alert on that. That's fine. You can build that in the Eventador platform and off to the races. But you may also want to store that detailed data somewhere else, right? Maybe you're dumping that raw stream to S3, and maybe you will run some sort of batch process on it later. That's another way we see it's very common. Or maybe you're going to put it into a data warehouse, and maybe that data warehouse is expensive, which they often are. In that case, you would maybe pre-aggregate the data ahead of time, and then just put fixed aggregates into the data warehouse. So maybe you're going to do it by week, by month, by day. And that way you're saving a ton of space with the raw data in something that's very expensive, like traditionally data warehouses have been. All that stuff is really enabled by platforms like ours, because you can take that raw data coming in from Kafka, you can build SQL processors on it, you can route data to different places, you can pre-aggregate it, you can dump it to S3. So all those things are kind of on the table. And I think like the best enterprises are leveraging tools in this way and thinking about it like, hey, get it into Kafka. And now let's think about in a very serious way, how do I get the data out and where do I send it? And who are my consumers downstream?
And in terms of how you've actually built out Eventador, I know that you have mentioned your affinity to Kafka. I'm wondering if you can just discuss the overall architecture of the platform and some of the ways that it has evolved since you first began working on it.
Sure. So there's some basic kind of design tenets and various areas that we've tried to solve. So, it's a service-based design. It's built on Kubernetes. Some of our services use open source technologies like Flink, we've mentioned that, and Kafka. But there's some like higher level components that were really important as part of our design. And that is, so first of all, schemas are hard. The schema that most enterprises have is not, if you think your enterprise has one schema and it's perfect, you're probably lying to yourself. Most data is very messy. Most companies are working through trying to standardize and ensure that their schemas are good. But it is tough. And in a lot of cases, it's the Wild West out there. So dealing with nested data structures, dealing with foreign data feeds, dealing with different departments, that's a big piece of the challenge. And that's why we created input transforms and have the deep nesting capabilities in our SQL engine, because we wanted to be able to address those feeds. We wanted to allow customers to mutate those schemas on the fly if they needed to. We integrate with things like schema registry if needed, and try to get that piece of the puzzle really nailed down. The other piece of it is a good SQL engine. So we leverage Apache Flink for the core SQL engine, but that's not really the whole picture, because if you use SQL in Flink today, what you're doing is you're actually writing Java or Scala code, and you're putting SQL into that Java or Scala code as a string, and it's evaluated at runtime. And, as we know, SQL is an iterative, declarative language. You want to be able to iterate on your data structures and on your data with SQL. You want to play around with it. You want to understand maybe what groupings are important or what timeframes are important. And then ultimately you decide like, okay, that's a good piece of SQL. I'm going to send that off and let that be a job and run continuously. So our SQL engine is pretty cool in the sense that it allows you to iterate on streams of data. So it understands the schema. You can describe them. It uses ANSI standard SQL based on Calcite, and that works nicely with Flink. And if you make a mistake, like in your grammar, like a syntax error, it will tell you right away. So you don't have to wait for that job to run and redeploy and go through CD and all that kind of stuff. So it really allows you to explore the data, play with it, treat it like a regular SQL terminal. And then, as you hit execute, it creates a job and sends it off to the server. It's highly scalable, robust, has robust capabilities around fault tolerance and things that, frankly, Flink brings to the table, and you're off to the races. And then lastly is this notion of materialized views. So we have an engine that manages materialized views for us. That's something that we wrote. It manages the update and maintenance of materialized views, the indexing strategies, and really lets developers then address that data with any key, not just like lookup by key. It's not just a simple key value store. It's an actual robust, RESTful endpoint. And so customers can build queries, they can send in parameters, they can, assign predicates, and then build queries and build applications off of it. So those are kind of the, from kind of the input and ingest to processing and then ultimately to materialization. Those are the big kind of pieces that we've added on top of the puzzle using things like Kubernetes and Flink.
And given the fact that you are materializing the views, I'm wondering what you're using as the durable storage for that transient data. Is it something that you're writing back to a Kafka topic, or do you have some sort of caching layer for being able to pull the current values from the materialized view based on the aggregates as they're updated? Good
question. So today we're based on the Postgres engine, and that gives us a ton of flexibility in terms of, first of all, it's a very good, SQL database. It's a very well-known and relatively bug-free database engine. And then our management layer that lives on top of it that treats it like a materialized view versus database is a big part of that as well. So our software mixed with, some of the Postgres open source goodness allows us to ultimately present those materialized views to the customer and keep them updated, age them out, and, do all the things you'd expect from a view that's being updated in real time.
Another element of the schema support and being able to capture the appropriate context of data as it's flowing in is the idea of enriching the records as they're being inserted into Kafka. And I'm wondering what type of support you have for being able to either join across different topics or materialized views, or adding a default set of data that gets injected as part of that input transform.
So first of all those things are possible on our platform. We're a little bit different in that we treat every input, whether it's Kafka or anything else, as a virtual table. So, and you can join virtual tables. So if you have a Kafka topic in the EU region and one in the US, and you need to join those in a piece of SQL, that's fine, no problem, super easy. If you need to join something like Redis, maybe you've got, like a common use case is like maybe with I don't know, I'm making this up, but like a voter application, and maybe you want to take geo coordinates and look them up by county so you can populate a map or something like that. You might just have that geo to county lookup database in a Redis database. So we allow you to actually enrich on the real time from Redis. So that's pretty cool. Super easy to use, as well as just use user-defined functions. So, in user-defined functions, if you have a static data structure you need to use or some sort of lookup table or lookup hash, you can go ahead and use that, in real time as well. So we kind of see all of the above. Sometimes, I think people start off with more static data sets and actually put it in the UDF. And then they say, oh, it'd be great if I could update this in the back end if I have some sort of database technology. And then, Redis is a great fit for that. So we see that as well. And then, obviously sources and sinks, which are the inputs and outputs of any, kind of stream processing system, are important. So, S3 is an interesting one. I think, going forward, we'll have more support for more what, I'll call legacy databases. But today, if you want to do change data capture, or you just want to use Kafka or any of those kinds of things, all those things are possible and work quite well.
And then at the time that you started Eventador, my guess is that Kafka was still the preeminent streaming platform for being able to handle this durable append-only storage. But the landscape has evolved fairly significantly in the past even just year or two. And I'm wondering what types of changes have occurred in the overall ecosystem since you first began working on Eventador? And if you were to start over today, how would the current state of the industry influence your design choices, and what would you do differently?
Yes, there are other options out there today. I think that Kafka is sort of the de facto standard. Each cloud kind of has their own little version of that as well. And I think that's kind of a second place at this point, like things like Kinesis. And, I think if I look back, knowing what I know now, I told you we created this initial prototype where we had kind of this end vision of materializing results through streams and SQL processor in the middle. I would have actually tried harder just to kind of get to the end result. I mean, I think we early on, and I want to be humble about saying this, I think we maybe, didn't necessarily predict where the market was going, but we kind of maybe felt that it was going to go this way, that it just kind of made sense. And, here we are now, and, materializing views on streams is a real thing. There's multiple people doing it. It's a well-known design paradigm. We didn't know that when we first started Eventador. We just knew that this would be a cool way to build things on streams. And I think if I knew where we're at now in terms of the macro picture of the market, I would have just tried harder just to get here faster instead of, we went through phases of where we thought, hey, it's going to be a managed Kafka world or a managed Flink world. And our software and our platform was going to be a smaller part of it. And I think ultimately we figured out that kind of the reverse was true. Kafka is very prevalent. Apache Flink is a very amazing piece of software written by very smart folks and a great list of maintainers, and continues to grow in popularity and is focus on correct results and good state management. So it is a great piece of software to work with and work on. And we're bringing what we can to the table, and I think it really, the sum of the parts really equals a really nice and powerful platform. And I think, like I said, if we would have known that before, I would have just tried to jump right to the end result. But you never know when you're building something, I suppose.
Another element of building on top of all these different types of systems is the operational complexity that it brings along with it, because distributed systems are hard in any case, but trying to layer multiple ones of them together and then provide your own SLAs on top of it as a reliable foundation for other people's applications. I'm wondering what you have found to be some of the most interesting or challenging operational aspects of building and running your platform on top of these systems.
Yeah, and that's a really good point to make, is that, once you start, if you want to build this, this kind of real-time architecture in your company, in many cases you'll have the talent to do it. Engineering talent is prevalent these days. And, and ultimately these applications are business critical. You're building something the business really needs to compete in its market space, and data is king, right? So the thought is like, well, I'll just go build this stuff, and, I'll use Kafka and I'll use Flink and I'll build this stuff myself. And, companies have. You've seen Uber build Athena X. You've seen Keystone by Netflix, and there's others. But those companies have put massive resource and massive time and energy into building these platforms. And ultimately, it just lets the customer self-serve and the development customer self-serve and build apps. And that's great. I think that if you're not Uber or you're not, one of these gigantic companies, monoliths, then you probably do need to think about vendors in this space, us or someone else, to help glue together a lot of these pieces. Because, like I said earlier, stream processing is a different mental state than database engineering to some degree. The same thing with kind of even if you're coming from the Hadoop, the distributed batch data landscape. These are very similar, but also very different kind of mind shifts in how you deal with streaming data, how late data is, you think about, late data, how you think about schemas in a schemaless world. How do you mix those two things? Obviously SQL requires strongly typed data and a fixed schema. That's also pretty common for people just to jam whatever JSON into Kafka. How do you reconcile those two events? How do you get a strongly typed schema out of a JSON blob that people are throwing into Kafka? So, these are, and then how do you support all that all day, all night, the whole time? And I think on a planet scale. And I think that, in those cases, you do need a good partner. You do need someone who's very good with support and understands the underlying technology stacks to help you keep these things running. I said earlier that, a lot of these are production business critical applications. And once you start to compete in your market space with, real-time apps and maybe you're running machine learning models or maybe you're just building really, really cool dashboards that customers are attracted to. So they're buying more of your product. Once you start getting those things up and running, you can't just back away from them. They're production jobs and it's very important to your business. So getting a good partner that understands that stack and the nuances within the stack, I think is a pretty key and core thing. And then understanding that, I should be able to, the state of the art, I think, for, the kind of the the end state that's great for companies that is that they can self-serve data. They can look at a stream of data. They can inspect it. They can pick the pieces they want. They can build their own filters and aggregations, and then they can self-serve it to whatever application they're building. Like that's the holy grail, I think. And you see, and that's why, AthenaX and the other platforms were built is so that, the data engineering folks, typically there's a few of them, even in big companies, can keep up with the demand from the business in terms of building real-time apps. And I think that's a really nice goal for us from a design aspect for Eventador. And I think, companies should be looking and thinking in that way as well, because there's only going to be more applications being built on streaming data going forward. And how are you going to keep up? And so that's why support and the right platform, I think, matter a ton.
You mentioned, too, that you're building on top of Kubernetes for being able to manage the actual infrastructure level. And I'm curious what you have found to be some of the useful elements of that platform and some of the challenges for being able to manage the stateful workloads on it.
Right. So if you've used Kubernetes, you'll know that I think it's a love and a hate thing. Look, I'm not a Kubernetes expert. The team is, but what I experience where I'm at is I see a lot of, hey, Kubernetes makes X really easy and Kubernetes makes Y really hard. And so systems are more opaque from a support standpoint. It is harder to figure out where something went wrong and rectify it. At the same time, when we need to scale a cluster, it makes it very easy. And if we have faults or problems, rescheduling jobs and delivering a seamless experience to the customer is easier. So it's a love-hate thing. I think Kubernetes is still relatively early. It's very powerful and makes a ton of sense for what we're doing, I think. But, going forward, I think it'll get better and we'll frankly develop even richer processes for dealing with support and how do we quickly identify broken things and fix them. So,
and going back to the SQL support, you mentioned that you support ANSI SQL using Calcite as the engine for being able to handle the parsing of that. I'm wondering, what are some of the ways that you have found necessary to extend or augment the SQL dialect for being able to support streaming workloads and some of the different ways that user-defined functions are incorporated into these workloads?
Sure. Yeah, that's a good question. So just, if folks don't know, Apache Flink has a SQL API, and that's ultimately what we leverage based on the things I said before. And that the dialect that understands is the Calcite, which is for the most part ANSI SQL. And Calcite's very broad. So Flink doesn't support 100% of Calcite because some of that stuff is more batch related and it doesn't really apply. But if you go to the Calcite page and you're wondering, if a piece of SQL works or not, then the Calcite's the right place to look that up. I'll say that Flink has been on a development journey, and with the acquisition of Vivarica with Alibaba and the Blink planner that Alibaba's brought to the table, I think even more SQL capabilities and richer SQL capabilities are coming forward, and that's great. And it already does stuff that's above and beyond the dialect for just simply Calcite, which is things like match recognize. And match recognize is doing complex event processing in SQL in a single set statement. It's really amazing. We use it a lot here. And so that's kind of an add-on from that standpoint. And then, like you mentioned, UDFs. So the way we do UDFs is a little different. We kind of harken back to our MongoDB days where JavaScript was the procedural language for the engine. And we have that here too. So the JavaScript gets compiled down to Java and runs in the JVM and sent out to the machines. And you can actually define that in real time. So we have an editor. You can build a snippet of JavaScript. It can be, something simple like, converting numbers or, looking up a particular value in a hash. Or it can be, farming out to a REST endpoint to enrich your data. And obviously that'd be slower, but, we have all that kind of capability. So case logic and procedural logic and, anything under the sun really that JavaScript supports, you can go ahead and build a UDF with that. And then you're off to the races. It's not one of those things where you have to recompile the server or build new jars or any of that stuff. It's just, you just define it and use it in your SQL just like you did in your favorite database, whether it was MySQL or Postgres or any of these things. It works the same way. You create a function and you're available to use it right away and you're off to the races. And we also use that JavaScript engine for our input transforms. So when input transforms are cool because if your data is coming in and maybe you have arrays without keys, or maybe you've got messy data that needs to be normalized, or maybe you're some of the data is just bogus. Like you just want to drop the data with a certain element and just not process it and only accept data with a certain schema or something like that. Input transforms work great for that. That's also in JavaScript. So, if you're using Eventador on a day-to-day basis, you're writing SQL statements in Calcite SQL, you're, augmenting that with JavaScript, with input transforms and UDFs. And then you're, creating RESTful endpoints that you're then pulling into your apps. So we deploy an endpoint and you can use that in your application. And then, you get return JSON data right from that endpoint. So that's kind of the different pieces of where they fit in and how kind of UDFs kind of sit in the middle.
As far as the workflow of somebody building on top of Eventador, how does it integrate into the overall development cycle and the software development lifecycle of being able to version and deploy the different queries or different user-defined functions that are powering people's applications and making sure that any schema transformations that happen are deployed at the same time as the applications that are going to rely on those different forms of the data?
Eventador has a notion of projects, and in Eventador you can write Java or SQL. You can just write Flink jobs and deploy them. It doesn't have to necessarily be in SQL, although we find most customers, enjoy using SQL because it's much easier and quicker to get the job done in most cases. In that case, we use projects, and we have a projects interface where that's integrated with GitHub. You can plug that right into your CI/CD pipeline and, integrate with the rest of your organization, and that way teams and all of that. Now, that's just for Java. SQL's coming. That's something we're working on right now. So the next thing you'll see, coming out from us is that you'll be able to check in the various components of your SQL job, whether it be the SQL, the UDF, the input transforms, all the things that make your job work properly, the configuration for the materialized view, all that stuff. And then that lives in your source repo. And then, when we launch a job, you can just launch from the repo. So that makes productionalizing and having a source repository versioning and CI/CD real easy. And we do that today for Java, and then SQL's next.
What have you found to be the tipping point where SQL isn't sufficient for being able to complete a particular task and somebody would want to drop down to writing the job specifically for Flink or being able to approach it in a more procedural fashion?
We get asked that a lot. And there's a number of dimensions to the answer that I think are interesting. So the first one is that, look, if someone's a Flink shop and maybe they've got a couple Flink jobs running and, now the business is relying on them and they're nervous about supporting them and how do I scale them, they can port those jobs over to Eventador, no problem. That, we'll just run those right off the bat and bam, you're off to the races. So from a transition and migration standpoint, it works really nicely to just keep using that Java, going forward. So that's one thing. The other thing is it just depends on who's in the team and what the mix of engineers is and the time frames that they have to complete a project. So, we had one customer, it's kind of funny, he Java guy, total dyed-in-the-wool Java guy. And he's like, yeah, I would like to write this job in Java, but I'm going to write it in SQL. And we said, well, why are you going to write it in SQL if you like Java so much? And he said, because I'm the only one who knows Java here. And if I write it in Java, then I'm going to be on the hook all night long for support and on call and all that stuff. And I'd rather write it in SQL so the 9 other people that work in my department can maintain it and change the job and mutate it over time if it needs to. So, it's not just a matter of, and I thought that was a very mature decision. Like I thought, okay, he's not trying to just, he's thinking about the team and what can we support going forward. And, look, he's looking out for himself too a little bit. He didn't want to be woken up in the middle of the night. So I thought it was funny. So, I think we see a mix of both. There are some libraries that, you can pull into Java that, and maybe you're used to, working in that IntelliJ is your home, then we support that too. And that's no big deal. But I think, look, it's like a 90-10 thing. 90% of almost all workloads can be expressed in SQL relatively robustly. 10% of the time you might need a specific library or you have a specific, workflow that you're used to or a code pattern that you're used to, and you'd rather do it in Java or Scala. So I think that's kind of where the breakdown is. Maybe it's 80-20 or whatever, depending on the organization. But for the most part, most things are expressed in SQL, and it's just because it's simpler in most cases. So I think that's kind of where we see it heading.
And as developers are working on building out these streaming workloads and building applications on top of them and trying to schematize the input data, what are some of the sharp edges or design pitfalls or data modeling considerations that they should be aware of?
Right. That is a huge topic in and of itself. Schema management and data quality honestly, it is a whole topic in and of itself. Some of the things that we've seen trip people up, though, are if people are pulling in data from multiple foreign sources, sometimes that's like a partner, sometimes that's a maybe a foreign REST API they're pulling in billing data or something. Other times it might be just departmental differences. Department A and Department B have different data structures for essentially the same thing. So that can be very challenging. And I think a lot of companies, there's different philosophies out there. A lot of companies say, hey, we want you to adhere to this rigid standard on the schema, and here's a document and how to do it, and here's a central schema repository, and kind of that approach. And we've seen that work and be successful. Another approach is that people say, well, let's just not burden them with that. Otherwise, projects will stall behind, waiting for schema approval or whatever. And let's just let them put the data into Kafka in the format that feels native to them, and then we'll build the tools that allow that data to be used effectively in the rest of the enterprise. And that's kind of where we fall. I think we're more powerful in that case. There's another company called Rockset out there. They automatically detect and handle schemas. We do that too. They're more batch oriented, although they're kind of they're seeing the writing on the wall, I suppose, too. Going more towards streaming. So that's great. So, I think we see that kind of, let the data just be the native format, and then build the tools to handle it in a more robust way, kind of design more often than not. And again, that's the one that we work better with. And that was like the philosophy of MongoDB way back when, right? The schemaless design, and ultimately everything has a schema, and the world doesn't exist without schema, but let's move it to the part where we absolutely need it, and let that data be persisted and saved in Kafka, and then used in an effective way with things like input transforms or UDFs, or just even being able to use, nested structures in SQL is another way to deal with that. So I guess that's kind of my thoughts there. I know that's not exactly answering what you're saying, but I think that's the real struggle is where do we fall on the militant level of deciding that there's a fixed schema, or do we let kind of, a loosely defined schema be the norm?
Yeah, the universal answer to any technical question, it depends.
Yeah. Right. That was only one. It depends. Maybe I'll have more. I don't know.
And what are some of the most interesting or innovative or unexpected ways that you've seen your customers using your platform and building on top of these boundless event streams?
We had this thing early on that I thought was super cool. Like I told you, we created input transforms and UDFs in JavaScript, and we saw folks starting to use them. And I remember we were on a support call, and they were talking to each other about our platform like it was, like with our vernacular, and like it was normal, like teaching each other our platform. And I thought, man, this is the greatest thing ever. I love it when, we come up with an idea to solve their problem, and they using it to solve a problem, and then they're teaching each other to solve that problem with the tool set. This one customer I was thinking of, they really doubled down on the input transforms, hundreds of lines of JavaScript code to process incoming data just because of the nature of that incoming data. And I think their use case is quite unique. Not everybody has the same problem, but the fact that they were able to just use that out of the gate and kind of got it and then, went with it. I was pretty proud and excited to see that happen. And frankly, a little surprised that it worked so well for them right out of the gate. And we've continued to modify it, make it better. And I think it's even more robust now. So that was really quite cool.
And in terms of your experience of building and scaling the Eventador platform and just working in the data management space, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think streaming data is harder than we thought it would be overall. I think when you, just like anything, it's kind of an iceberg in the sense that you start putting data into Kafka and you're like, okay, I get it. And maybe you create a consumer group and you've got a microservice and you're pulling data out and you're like, okay, this is cool. But that's like, that's the aha moment with streaming data. But to then go from that to my company runs and my production applications run on streaming data is a whole different thing. Entirely. It was sort of like in the MongoDB days, it's like, okay, it's super easy to put data into a Mongo database, but now I need to shard that database, and now I need to, index those nested structures or whatever. It starts to get complicated quick. And I think that is, ultimately, like when we're thinking about things like out of order data and back pressure, streaming data is a mindset shift from database technologies of old. It's extremely powerful in your applications, but it does require you to think differently about how it all works. And I think that's one of the things we have really worked hard on is to make it feel and work like a database, so that folks don't have, isolate them from as much of the detail of how sausage is made, so to speak, for streaming systems as possible. And that's, all about using SQL and all about materialized views and those types of things. So from a high level, that's kind of where I think it was harder than we thought. I also think that, and I said this at the start to some degree, I'm pleasantly surprised and excited to see more folks most of the time, I guess you'd say it would be bad to have a lot of competitors. But I think if I just take it from a kind of work, from a personal career standpoint and from a craft standpoint, the thing we're building and the thing we care so much about and build every day, think about all night, I'm really excited to see a lot of other folks in the space. I mentioned Materialize earlier, and obviously the Confluent folks with KSQL DB, Rockset I mentioned, and there's others, there's Keen.io, and there's a few other ones they're great companies building really cool things. And it's nice to see this ecosystem evolving and customers to be successful with these stacks, whether it's us or someone else. I like to see that the community is getting it and growing, and it's really, really satisfying to see someone build something cool and like say, oh, that was kind of easy. And you're like, yeah, well, okay, I'm glad it was easy for you. We figured out some of the hard parts of that for you, and I'm glad we did. So I don't know. That's kind of where I suppose I land on that.
And what do you have planned for the future of the Eventador platform?
Sure. So, we want to continue to make application developers, data scientists, data engineers successful with streaming data. The theme, I guess I keep talking about is, this stuff is hard. There's a lot to it. And ultimately, you just want to build that killer application. And you shouldn't have to have, your knowledge doesn't have to span all the way into the depths of all these different components. Maybe your company already has Kafka and you just want to make sense of that data and just drop in and start building. And so those are the folks we want to continue to make successful with our product and build great things. And I think the world, especially now, has more data problems than ever. Data is now and will continue to be the most important thing a company has beyond its people. And you have to make sense of that data and you have to use it competitively or you're going to die. And using streaming data to do that is the killer app. And I think that's super exciting. So, our path is to build more APIs, do things like automatic fault detection and automatic scaling, use the clouds more effectively in terms of cost controls and scalability components. So we have feature sets in all those different areas. We plan to continue to, I think our REST API is very robust in terms of its capabilities of secondary keys and operators and things like that. But we want to continue to build on that too. We know that flexibility in the API and usability to the developer is going to be key. So that's one area we're going to continue to invest and build on.
Are there any other aspects of the work that you're doing at Eventador or the overall space of streaming SQL and event streams and building applications on this real-time data that we didn't discuss that you'd like to cover before we close out the show?
No, I think that's a pretty good overview of streaming stacks these days. I think, we'll see I think the next year and a half or 2 years is going to be really exciting for this field. I think that, ultimately customers are going to understand that they should be building self-service platforms for this stuff, that their customers, the developers or data scientists, need to be able to have access to this data. I think data science in general is going to grow to understand that streaming data can be a big part. I think today, if you asked a data scientist what does data look like, I don't think necessarily across the board a huge segment of them would say, oh, it's streaming. I think that's going to change. And I think, we'll understand that data in movement has more value than data at rest across the board. And we'll see some more exciting, innovations coming from those teams of people. So I think that's exciting. But yeah, that's, I think, it.
For anybody who wants to follow along with the work that you're doing or get in touch, I'll have you add your preferred contact information to the show notes. And as a final question, I would just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today. Sure.
I think ultimately, users of data in an enterprise don't know what data they have. They don't know how to use that data effectively in their apps or in their projects, whatever they're building. And I think data discovery and understanding schemas, as we talked about a little bit, and having central repositories of this data easily available, not just in the streaming sense. I think across the board has been a big challenge for companies. I think I said, look, it's not just databases anymore. It's databases and batch and queuing and all sorts of different data systems make up a robust information architecture these days. And I think that just means more sprawl and more confusion. And I think that's a big area that is still kind of uncharted and left unfixed, so to speak, or unaddressed to some degree. So, well, thank you very much for taking the time today to join me and share your experience with building out the Eventador platform and
working in the space of streaming data. It's definitely a very interesting and challenging domain, so it's great to see people like you out there trying to tackle it. So I appreciate all of your time and effort on that front, and I hope you enjoy the rest of your day.
Thanks, Tobias. You too.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.